Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we're going to discuss in our today's video is magnitude and direction of a vector. Let us start with the magnitude. The magnitude of a vector AB is nothing but the length of the line segment AB. We generally used to denote the line segment by AB with a dash on that. Now let us denote the vector. This is how we denote the magnitude of a vector. You can also say this as a distance between the initial point A and the end point B. In symbols, we denote it in this way with a modulus sign on that. And obviously magnitude is a positive one. It can be either a positive number or 0. Now let us see the formula to find the magnitude of a vector. For this vector, let us find the magnitude. I'll give you the formula first. Here is the formula, square root of u1 square plus u2 square. We can also calculate the magnitude of a vector when the coordinates of the endpoints given. For example, let this coordinate be x1, y1. I'm not going to take any number. I'm just going to assume it to be some coordinate. And let this coordinate be x2, y2. Now I'll show you the formula for AB. When you get two coordinates, a pair of coordinates at the endpoints, you can use the distance formula. Because vector is nothing but the length, no? Length and distance from one point to the other is the same thing. Am I right? So you can directly use the distance formula when you get two pairs of coordinates. Now let us see magnitude of vectors in 3D. This is how the coordinates of a three-dimensional term would be. You'll be having x, y and z generally. Here I have assumed just u's. Now I'll show you the formula. Here when you get three coordinates, you cannot able to use the distance formula as it is. You have to make some changes too. Okay, I'll give you the vector formula for magnitude. So here is the formula to find the magnitude of a vector in three-dimensional. Hope you're clear with the formula. Okay, let me show few examples in both two-dimensional as well as three-dimensional problems. Here is an example. Let us find the magnitude of this vector. U is equal to 3, 4. So you can use the formula square root. Square root of 3 square plus 4 square, which is nothing but 25. Square root of 25 is 5. So this is one type of problem you generally get. Now let me take an example with two coordinates, just like starting point and ending point, and show you how to find the magnitude. So here is the second example. Please note that we have two pairs of coordinates, x1, y1 and x2, y2. Now we are supposed to find the magnitude of this vector. So how can we find this? Yes, we are going to use the distance formula for this one. So you have to write the correct notation. So after writing the correct notation, apply the correct formula. So if you simplify this, 2 minus 1 is 1, and by simplification I'm getting square root of 26. Please check whether you're getting the same value. You have to simplify the answer as much as possible. Hope you're clear with these two examples in two-dimensional. Okay, let me take, these questions are very straightforward. They have given the values, you just have to apply the formula. Now I'm going to take one example where you have to find the one of the value when the vector is given. Okay, let me take the question. Here is the example. Okay, now let us find the k. Here magnitude is given. Okay, first let me write the formula. Now I'm going to plug in the values given in the appropriate places. Vector is 5 and in the place of x1 we have k and replace y1 by 3. Now let's expand this one. I want to find the value of this variable, but the variable is under the radical. I want to get rid of the square root. So what can we do? We have to square both the sides of the equations. So we will get, now work out the exponents, subtract 9 from both the sides, and then we need to find the value of k, but we have k square. So what can we do? Yes, reverse of the previous operation we did. We are going to take the square root on both the sides. So we will get two values as the answer, because this is just like a quadratic equation, no? So whatever answer you're getting, you should write a positive and negative sign before the answer. So square root of 16 is 4. So I'm going to write plus or minus 4 as the answer for k. So you may also get problems in a straightforward manner or like this. So this is all about the magnitude of the vector. I would also like to give one example in three-dimensional. Okay, let me give you. Here is the formula for that one. So this formula will be very helpful for you in the calculation of the module, knowing the coordinates of a point. Okay, let me take one example. Plug in these values in the place of x1, x2 and y1, y2, z1, z2. So let us just plug in. By simplification, we'll get 6 the whole square 36, 0 the whole square 0, and negative 9 the whole square positive 81. And this is going to be square root of 117. Hope you're clear with this example. Okay. There is two more thing also. We can also calculate the magnitude of a vector by a scalar product. In this video, I'll just give you the formula. In the other video, I'll explain that concept with suitable examples. Even by the scalar product, you'll again get the u1 square and u2 square. Am I right? So one must be familiar with the scalar product also. That is also one way of finding the magnitude of a vector. Same way for three-dimensional. So by the scalar product, you'll again get u1 cube, u2 cube and u3 cube. Let me take an example for each one of the formula. Let's find the vector of u. So if you plug in, it would be 3, 3 plus 0 times 0. Does this make sense to you? Okay. Now let's find an example. Okay, find the magnitude of the vector with three coordinates. Both by the normal method as well as the scalar product method. You will get the same answer because squaring and cubing is same, no? Okay. Here, scalar product only for twice. So u1 times u1, u2 plus u2 times u2 plus u3 times u3. So let's plug in the values. Minus 3, 2 and 5. 9 plus 4 plus 25. So square root of 38. Hope you got an idea on the magnitude of a vector. Now direction. Direction of a vector is nothing but the measurement of the angle which is made with the horizontal line. The direction of a vector is the measure of the angle it makes with the horizontal line. So one of the formula can be used to find the direction of a vector. I'll give you both the formulas. These are the two formulas. First one is tan theta equal to y over x, where x is nothing but the horizontal change and y is nothing but the vertical change. Or you can also use the second formula, which just looks like a slope formula. Tan theta equal to y2 minus y1 over x2 minus x1, where x1 and y1 is nothing but the initial point and x2 and y2 is the end point or terminal point. So for the same set of x1, y1 and x2, y2, you may be asked to find the magnitude as well as the direction. Okay, let me take one example. Here is the example. Find the direction of the vector PQ whose initial point P is at 2, 3 and the terminal end point is at Q, which is at 5, 8. The coordinates of the initial point and terminal points are given. So let us just substitute them in the formula. So since we have two pairs, you can just use this formula, second one. So by plugging in, we will be getting y2 minus y1. So 8 minus 3 in the top row and 5 minus 2 in the bottom row. 5 over 3. And then you can take the inverse tan. You can also use calculator in this part. So theta equal to tan inverse of 5 over 3. By using the calculator, I am getting tan inverse of 5 over 3 as 59 degrees approximately. Therefore, you can conclude this answer as the vector PQ has a direction of about 59 degrees. Hope you're clear with this example. The direction of a vector is often expressed as an angle of rotation of the vector about its tail. So this portion is tail. Or you can just imagine the directions: west, east, north, south. Please have a glance over this. For example, a vector can be said to have a direction of 40 degrees north of west, meaning a vector pointing west has been rotated 40 degrees towards the northerly direction. Okay, the direction of the vector is often expressed as a counterclockwise angle of rotation of the vector about its tail, from due used. So this is one of the most common conventions for the direction of a vector, and you can utilize this while solving the problem. Now let us come to a conclusion. Vectors can be represented by use of a scaled vector. Okay. So each of the arrow, I mean a vector, has an obvious tail and an arrowhead. Magnitude of the vector is represented by the length of the arrow. The scale, you can take of any scale. It should be drawn in a proper length according to the chosen scale, whatever angle that you are choosing. the arrow points in the precise directions. And the directions are described by use of some conventions, which I told you just before. So it is nothing but the angle of rotation in the counterclockwise. Hope you're clear with this topic. In case if you get any query regarding this topic, kindly let me know.